shout out Jacob Pittman. He's not here in class today.
But we miss him.
But we miss him. And I hope you find this math lesson interesting. And I hope you learn a lot from it. And I hope you're back tomorrow. And do good on your test.
All right. What questions do you have on your homework? You want to start back in quadratics? So worksheet 7 and worksheet 9 were the quadratic worksheets from the old packet. So we did a lot of calculator work on 9. 7 was a lot of algebra fun. And I feel like it's been a while since some of you looked at this because you totally did your homework a week and a half ago when it was assigned. So maybe you should look at it again. Do you have any questions? Nope, not all of them. Let's start on worksheet 7. Does anybody have any questions on worksheet 7?
Hold up.
This is going to be an awkward video. Should I? Oh, yes. Number 7 on worksheet 7? That sounds perfect. All right, so this is on worksheet 7, number 7. They want to know the vertex, the y-intercept, and the x-intercepts. So the function itself looks like this. And it is in standard form. So as far as like what good is standard form, not much. It tells you a few things, but out of our list of things that it does tell me, the only thing it already tells me is your y-intercept. So you should be able to answer part B, because in standard form, the y-intercept is where you plug in a 0 for all your x's, which would just give you 0, 12. The other things we're going to have to find. So I like that you asked this question because this tells us some other things that are coming up on the worksheet as well. When you're going to find the vertex, there's a few ways you guys can figure it out. I gave you 2 methods, and it's all like a preference thing. So for many of us, the way we start finding the vertex is we use our symmetry formula, which is negative b over 2a. So on this problem, that would be what? Negative 10 over 2 times 2. Oh, that's gross. So that's negative 5 halves, or you can call it negative 2.5 if you'd like. That's the x value of your vertex. The center of your parabola is found by using this formula. So, sorry. Now we have to plug that into there. So good news, you do have a graphing calculator on this test, so you could use your table, you could use your home screen. But when you plug in negative 2.5 for all your x's, I think you get negative 1/2 or negative 0.5. So there's your vertex. But do you guys remember there was an alternative way of finding vertex? Abruzzo's favorite, completing the square, the modified completing the square. I'm only bringing this up because I think some of you have used this and you've been very effective at it. Completing the square is less work, but well, what I call it is treacherous work. You've got to be real stinking careful when you complete the square on this one. So the first issue is there's not a 1 as your first coefficient, so you'd have to remember to factor the 2 out. The plus 12 just kind of gets shoved to the side. But factoring a 2 out of just the beginning of your quadratic, that's going to leave you with x, oh gross, never mind, I don't really want to do this. X squared plus 5, x plus wah. Alright, this is bad news, Abruzzo. Why? Because when I go to complete the square, I'm about to get fractions. So I'm not too sad, though, because you do have a calculator on this test. So 5 halves squared would be a 25 over 4. But this is really 25 over 4 times 2. So that's 25 over 2, which again, you have a calculator. But remind me, guys, because of my method that I'm using here, I don't add the blank, I have to subtract the blank. So I'm subtracting 25 over 2. Okay, so I kind of regret saying I wanted to do completing the square on this one, because I'm not really that excited about it anymore, but that's okay, we'll keep going. Alright, so 2, this factors into x plus 5 halves squared. And then when I add these guys together, that gives you a minus 1/2. So I still would have been able to get the vertex using this method. Negative 5 halves, or negative 2.5, comma, negative 0.5. I brought up that method because there is a question on your test where it says write it in vertex form, and you have to make a decision. Do you want to use this method where you use the symmetry line, or do you want to complete the square? And I'll be honest, I really love completing the square. So like sometimes I don't even care if it's a fraction. I just love it so much. But if you don't love fractions and you're looking ahead in your work and you're thinking, oh, if I was to complete the square, I'm going to have a fraction, then don't do that method. Use this method instead. Okay, but just so we're clear, I made you guys do those without a calculator when we learned the lesson in practice. You do get a calculator on the test tomorrow, a graphing calculator. Got it? Got it. Part C, they want the intercepts. All right, so the intercepts is the solutions to the quadratic. So you need to take your quadratic and you need to solve it. And I think I warned you guys, every one from this lesson was factorable. So because we're solving, you can actually just go ahead and divide everything by a 2. So then you end up with x squared plus 5x plus 6 equals 0. And then that factors beautifully. X plus 3 and x plus 2. So your x-intercepts are at x equals negative 3 and x equals negative 2. And if you want to get super fancy here, guys, the intercepts are ordered pairs. So you can write it as negative 3, 0 and negative 2, 0. I would be very impressed if you wrote all of your intercepts in proper ordered pair notation. Why'd you laugh at that? I would be impressed. Ha ha ha. I laugh at awkward times. Okay, what else you got? Yeah, you're real shy, Cameron. Alright. What else you got, guys? Anything else on worksheet 7 that really bothered you? I know I took a little detour in there. Yes, Piper? Oh, that's a good one. Okay, so number 1 is a little unusual because they're asking for weird, or they give you weird clues is the issue. So it says we have x-intercepts and a y-intercept. And normally when I had you guys do these questions where you create the function, I always had you start in Vertex Form. But the only reason we kept starting in Vertex Form is because they kept giving me the vertex. So this time I'm not going to use Vertex Form because they didn't give me the vertex. They gave me intercepts. So I'm going to have you start in Intercept Form, which is basically just factored form. That's Intercept Form. So there's a mystery A out in front, and then the factors are the x-intercepts. So what were those two x-intercepts they gave you? A negative 3 and a positive 1. So I'll do this. Negative 3 looks like that now. And then a positive 1 looks like that. But wait, there's one more clue out there. They gave me one clue that said it goes through a y-intercept at 0, 2. I can use this as a random xy ordered pair. So I can plug in a 2 for all my x's, a 0 for all my x's, and a 2 for my one y, and that'll only leave a to be a variable. So 2 equals a, and then we have what? 0 plus 3, and then a 0 minus 1. So if I kind of take inventory of what I'm working with now, there's only one unknown thing left in this problem, and that's this little a right here. So simplify, simplify. This is a 3 times a negative 1 with an a in front, and it equals 2. So I heard I should divide both sides by negative 3. And all we just found, guys, was a. It's negative 2 over 3. So now I need to go back to this step right here. And I need to back it up and say, whoop, I know a is now a negative 2/3. That was a hoot. So I think you guys have caught on to this by now, but as we get to harder and harder pre-calc, which we're getting there now, your work becomes more elaborate. These are not going to be like, oh, here's my answer because I did it in my head kind of questions. There's going to be work on many questions in your homework check. So when I go through and I spot check your homework check, I look for a couple things. First, I look for completion. Then I look for certain problems that I know have quite a bit of work on them. This being one of them. So I'm going to look at number 1, and if you have just the magical answer and no work, I know that you are a cheater, pumpkin eater. And you lose your point, and therefore you lose your fast pass, okay? So there's certain questions where I'm like, oh boy, that is clearly a copy from the key moment, and I'm not giving you credit. Goodbye, fast pass. Got it? Yes, Cameron.
Can we do number 6? I just don't know how to find the A.
Would love to. Alright, 6, there's a question like this on your test, so no problem answering these. And guys, I don't care if I even never get to look at your review today because Mrs. Hoffbauer's answer key that we posted has all the work on it. So if all we do is look at homework problems, that's going to really benefit you for two reasons. The homework completion, obviously. But also, these are questions that are on your test. So we're still reviewing. It's not like we're wasting any time. So at number 6, there should be 2 ordered pairs that we can identify. First being the vertex. I'm thinking the vertex is located at -2, 3. Can we confirm that? All right, cool. And then there's some other ordered pair. I'm going to use 0, 2. That feels like a good one to use. So the vertex is your H and K. But this extra ordered pair is just a clue. It's going to be a clue about an X and Y. We're going to use it to find A, and then once we use it, we throw it away. So because I have the vertex this time, I'm going to start by throwing everything into vertex form. Good. So I know a Y value from this random ordered pair was a 2. I have no clue what A is yet. Don't forget to square this binomial piece here, guys. That's usually what kids forget. All right, so the X value from that ordered pair was a 0. And then we're subtracting the H. So you're subtracting a -2, so this becomes a +2 right there. And then plus K, which is a +3. All right, time to simplify. Think about order of operations and simplifying, guys. You got to do this parentheses exponents thing first. You could subtract the 3 right away. I'm okay with that. Just be careful that you're not doing anything weird with order of operations. So this becomes -1 equals A times, what's really going on here, guys? This is a 2 squared, better known as 4. So now we can solve for A by dividing by a 4. So apparently A is -1/4. So now we go back up to this step. You're going to use the A equals -1/4 clue, and you're going to use your vertex clue, but do not even touch the XY ordered pair anymore. We just used that to find the relationship between A and X and H and K and all of them. All right, so Y equals A, now we know, is a -1/4. And then in the parentheses, it's going to be an X plus 2, I heard. Very good. Don't forget squared on that parentheses. And then plus 3 on the end. There's your formula. So we had to take a bit of a detour to find A. You have to show the work on all of those to find A. It can't be like well, I just looked at it and it felt like that answer, and then I looked at your key and I fixed my answer to match your answer. You gotta show the work, okay? Yeah, and the A's are not going to be like nice numbers. Like you're not going to see A of -1 on your test tomorrow. It's going to be funky. So there will be no estimation. It'll be all algebra. Alrighty. What else? Worksheet 7, 9. We're still in quadratics land. Number 2 on that same worksheet. It's the same thing that we just did, so I'd rather not do it. Yes. Yeah, so worksheet 9, side B. Number 10. Oh, I will do it, but I will also tell you something that will help you sleep easy tonight. There's no farmer pen questions on your test.
Yes.
Everybody hates the farmer pen question, including me. But I'll help you with this one, okay? I probably won't finish it up, but I'll help you set it up. There will be a question like 11 and 12, the person selling stuff and what happens when you increase the number of stores you visit. So we should probably look at one of those. Okay. So 10 for sure. Yeah, it's a fun time. So we gave you this farmer pen. And I don't know if they labeled anything originally, but let's talk about the fact that I don't know anything about this farmer pen. So what would you like to call these little red pieces that I'm highlighting? X sounds good. And then this longer piece, let's call it something. I prefer you not to call it Y.
Z.
Oh, wow, getting fancy. I heard Z first. I'll go with that. I'm gonna do a European Z.
Yeah.
Look at that.
Yeah.
Because if I just draw a Z, they look like 2s. So I get European on that one. All right. So, all right. So we do have a couple of clues. Not much. The farmer wants to use 500 feet of fencing. So that's the perimeter idea, right? Well, it's not really perimeter. It's more than perimeter. It's got an internal perimeter too. What would it look like if I add up all my pieces of fence? Let's do that. 1, 2, 3 X's plus 2 Z's. And it's supposed to equal 500. That was like the one clue they gave me. Now, eventually, I need to set up something for area, but not yet. Because I know how to find area, right? In this rectangular shape, it would be x times z. But I can't type that into my calculator. My calculator is going to give me nonsense back. So I'm wondering if you guys could come up with a way of saying z that doesn't call it z. Let's go over here. Can you rearrange this so it's another formula for z?
Yeah,
I think you can. And you don't even have to make it pretty, guys. Just subtract the 3x and make a big old divide by 2. If you want to divide by 2 separately like this, you sure could. Because I heard Cameron was just telling me 250 minus 3/2 x. That's beautiful. That's a z, by the way. It looks like a t for some reason. So this gets thrown in for that. Whew!
Okay.
So now I'm ready to talk to my calculator. And I'm going to say, calculator, I have an expression for area for you. And it looks like this. You're going to need to graph this by setting up your appropriate window, and that's kind of the challenge, but this is actually where I'm going to leave you. They want to know the dimensions of the pen eventually, so you're going to end up with a lovely looking quadratic that, you know, once you fix the window, it'll look something like this. You're going to find your maximum over here, but which part of this maximum ordered pair is going to help you figure out the dimensions? Yes, so whatever this x is, then you're going to know that one dimension for the pen, and you can plug it into this guy here to figure out the other dimension for the pen. So I know that's like the worst possible moment to leave you, but I'm going to leave you at that part. But I'm going to pause the video. Sorry, Jacob. While everybody else finds their answer, and then we'll come back and start the next question. All right, and we're back. Want to move out of quadratics? Want to move into the newer stuff? Okay. New stuff, which is all bookwork, if I remember correctly. So tell me, if you're asking a question on this newer bookwork, what page we're on, so I'm looking at the right page as well. We did have several bookworks. Yes, but that's alarming. So page 9 and 10, 11 I think is one of them. Page 19 is one of the last ones. Anything? Anything inspiring you? No? Nothing.
Yeah, oh yeah, that's right.
On page 11 and 12, which one? Oh.
No. Yeah.
Oh, yes. Yes. Oh, thank you. Yes, back.
Forgot.
I almost forgot. Yes. Do you have a preference, 11 or 12? They're both great. Okay, 11. So, they will, on the test tomorrow, you will have like the headings for the chart. The chart is not like super important. What's important is that you guys can come up with the algebra from the chart. So I have kids every year who are like, I really don't want to fill out the full chart. And I'm like, okay, it's there to help you. But if you're amazing and you can come up with the algebra at the end of the chart, and that's all you write down, that's okay. But you have to write something down. So the clues that they give you on number 11, a basketball team charges $4 per ticket. And then the attendance on average is 400 people. So to find revenue, they would multiply those together, and you would get $1,600. But then things change if you start upping the price, or decreasing the price. So if you decrease the price 20 cents, so that would be like $3.80, you're going to increase the attendance by 40 people. Right, so could I get a little calculator assistance on that one? Although this number isn't really crucial, but that's okay. Since I'm already almost done with it, let's just find it. Thank you. So this is where we can stop coming up with general examples and just start going to algebra. How do you write how I move through this column here? If you start at 4, how do you move to? Good. 0.2x. Very nice. 4 minus and then 0.2x. You're taking away 20 cents each time you move down the column. How about this column? How do you move down? Good. 400 plus 40x. So this is a quantity, and then we know from our math we were supposed to multiply it by this quantity, and that's how we find the revenue. So friends, this is what we're typing into our calculator. So in Y1, you crank this into the calculator. And you will have to adjust the window, but you know what? I'm always an optimist. Maybe your last window works for this one. So just try hitting graph and see if magic happens. Sometimes it does. But eventually you're going to get a quadratic that looks like this. You do need parentheses around your quantities, yes. And I need you guys to find the ordered pair of the maximum. Now, was the window not great? Is that what I'm getting? I mean, as long as you can see the top, it's a little, gotta get the bifocals out, huh? I need you to find that ordered pair that's at the maximum. And make sure, you guys are making sure you're putting parentheses around these quantities, yes? Can't really see it. Maybe if I just keep writing over the top of it.
I can't even see my cursor. Oh, there we go.
Okay.
Left bound. Seems about right.
Is it 5 comma something?
Yep. 5 comma 1800.
Okay. So now your job is to interpret this ordered pair. Because a lot of kids, they know that the x is the important part of that ordered pair. So they write down like x equals 5 and then they walk away from the question and then they get it wrong. The question says, what is the price of the ticket that they should charge to maximize their revenue? So y'all need to go up to this little expression and figure out the price of the ticket. And I think the price of the ticket is $3. So I would hate for you to do all that work, come up with a quadratic, the good window, the max, and then not get the right answer because you can't read. So be careful. It's like that on the test too. You got to go back and read the question before you commit. Alrighty. Anything else in quadratics land before we do move on? Okay. Is there any of that bookwork coming up that we need to talk about? There's functions, there's domain and range, there's evaluation of functions, there's symmetry questions. No? Nothing? Jemima, yes. What page number is it? What? Oh, is it last night's homework? Okay, I can, but it's not on the test. So, another day? Okay. Anything? Yes. Yes. Which one, I'm sorry? 21. So page 19 to 21, whatever we fall in there, but it's number 21. All right. 21 says, find the y-intercept and the zeros, and then find them algebraically. I'm pretty sure you guys are amazing on the calculators for finding those. Should we just focus on the algebraic part of it? Okay. So the function is 6x squared, minus x minus 2. So if I ever ask you guys to find y-intercepts, that's where your parabola is going to cross the y-axis. So by definition, that is where your x equals 0. So you're supposed to plug in a 0 for x. So think about that. Plug in a 0 here, plug in a 0 here. You get 0 minus 2, better known as negative 2. So y-intercepts, really easy to find in standard form. Awesome. X-intercepts take a little bit of work, because x-intercepts of any function are the solutions to the functions. So you need to set your function equal to 0, and then you need to solve it. Well, excellent news. You guys are wonderful factorers. So you're going to be able to factor this for me. I hope. Well, there's a few ways to get a 6x squared. Are you feeling 6 and 1 or 3 and 2?
3 and 2.
I'm feeling 3 and 2. Now I know not to put a 2 here for the 2 and 1, so let's put a 2 here. And then watch your signs, because I want my middle arches to add up to negative 1. So what if you made this 4 the negative 1, and the 3 the positive 1? So just triple check your factoring before you commit to solving. Those are factored properly. So now to find your solutions, you just set each factor equal to 0. And you solve. So this guy gives you a, let's see, we'd add the 2 and divide by 3, so 2/3. And then this one, you'd subtract the 1 and divide by 2, so negative 1/2. And maybe that's what you were thinking from the graph when you first peeked at it. You could have found those intercepts using your zero finder on your calculator too. I think they kind of wanted you to do that first and then confirm it algebraically. But, like, if I'm being a lazy student, if I know I don't really have to practice finding intercepts on the calculator because I'm amazing at it, and my teacher can't see my calculator, like, I probably won't bother doing that stuff on every question. But I will definitely show my work because it said to confirm them algebraically. Okay. All right. What else? It's getting awkward again. Do you want to start looking at the review? All right. Of course. I don't know why I don't have a picture of the first question. I apologize. But remember, you do have a graphing calculator. So you should be able to accurately graph me a nice, decent parabola using various points, whether you find them yourself or on the table, I don't care, but a nice drawing of the parabola. How about this question, though? This is kind of in the vein of, and I apologize, someone asked me about it, but I forgot who. Someone asked me about the question off of worksheet 7, I think, where you had to find the vertex at some point. So you can either start by using that symmetry formula, or you can do that modified complete the square stuff. You know I love completing the square, people. But if you don't love it so much, don't do it.
Can you just, like, plug the quadratic in your calculator? And
find the vertex?
Yeah.
I mean, technically, but I'm going to want to see work. You can do that to confirm. How about that?
I write down steps.
No. But that's very clever of you, and I appreciate that.
So I first second trips.
So I heard this method if someone wanted to see it. I mean, that someone was Taylor, who's obviously my favorite because she chose completing the square. CTS. Now, if you're going to complete the square on this one, cool, but we're going to have to factor out a 6. So that quadratic becomes x squared minus 4x. Oh, this one's not too bad. Plus a blank. That plus 5 kind of gets shoved to the side, and then we're going to have to subtract the blank to balance everything out. Talk to me, though, about what goes in this blank. Half of this squared is a 4, but this 4 is really a 24. So make sure you're subtracting 24 there. So 6, x minus 2 squared minus, I can't add, okay, minus 19. So your vertex clearly at 2, negative 19. Now, my friends who did that another method, maybe they found the negative b over 2a.
Yeah, that was so easy.
Well, yeah, it works fine, right? 24 over 2 times 6.
Plug it right in and then...
Right. You got x equals 2, and then what'd you have to do next?
And you
plug it into the whole quadratic, and you got a negative 19. Excellent. So, dealer's choice on that one, you know? I just really love completing the square.
I hate it.
That's, you know, potato again.
I don't like it. I don't hate it.
You did think that one function was beautiful, so you have a weird opinion of math.
That function just was appealing to the eye.
Alright, so this one you have to write in vertex form. So again, 2 schools of thought. You could do that negative b over 2a business, or you could try to complete the square. I'm gonna warn you, completing the square in this one is a little more treacherous than the last one, because what would you have to factor out? You'd have to factor out a negative 2.
Oh.
Ew. So if that changes your tune and you're like, yeah, never mind, I'm going to go the Cameron method, then go the Cameron method. So, I'll be honest, in general, Algebra 2 and PreCalc kids, this is the method where I see less mistakes. So if that's your deciding factor, then go with this method. Okay? Alright, we're going to be a little short on time, so let's kind of scoot through here. This question, this is like the one you guys asked me on your homework, where they give you a vertex, which means they're giving you h and k, and then they give you a random ordered pair. So they're giving you a helper x and y that'll help you find a in a minute. So because they gave you the vertex, you guys should all start in vertex form, and then start plugging stuff in. So you're going to plug in, you know, the y value and the x value you have, You're going to plug in the h value and the k value you have. And then you're going to have to do a lot of work, which I don't have time for right now, but Hofbauer's key has a lot of work on it. You're going to find a, and then you're going to come back and you're going to give me the function with the a and the h and the k plugged in. Okay, just like on your homework. If you've never touched that homework assignment until today, you need to work on it tonight. Okay, that's a tricky question. And I warned you guys, the a value is going to be a little funky. It's not going to be like a 1 or a -1. It's going to be weird. All right. Quadratic applications. This is using your calculator. You got to adjust the window and find when it hits the ground. Can someone remind me what command in the trace in the calc menu? So you go to second trace. Which one helps you figure out when the parabola hits the ground? Yeah, so you're going to choose number 2, which is the 0 finder. And we're really trying to encourage you guys to first make an estimate, like, oh, it appears to be roughly 9 seconds. So when I ask you the left bound, right bound stuff, you can just hop. Like, if I think it's at 9 seconds, 8 and 10. Yes, perfect. This is that seller's question. You will have the headings to the chart on your paper on your test tomorrow. You don't have to come up with the chart. But I would like to see something on that chart. So whether it be the whole shebang or just the algebra, that's fine. But remember, you want to go back and plug in your X to find the actual answer to the question. Because they want to know the total number of salespeople, not just what X is, but the total number of salespeople. Yes?
When on the last one, when I plugged it in,
yeah,
the X, it just came out with a Y.
But you're not plugging it into the whole function. Remember on your chart how you have like 2 algebra pieces? Where like this one, let's see, average number of salespeople. So this is like the average number of people. And this is like the number of stores, maybe. So you're going to come up with your algebra, and if it wants the total number of people, that's what I'm looking for. So whatever algebra you put here, you're going to plug X into that.
Oh, so you don't have to do the whole thing?
No, if you plug the whole function in, you're finding the total revenue. Which they didn't ask for. They could, but they didn't.
They could?
I'm not going to. Just to be sneaky, I'll ask you something I've never asked you before.
What?
That would be rude. Okay, so some basic evaluation of functions. Just plug them in. Watch your parentheses, or do you guys remember that cute little storing mechanism? You can do like -1 stow x, and you can do it that way. You don't have to. Just remember, guys, when you're squaring a negative number, you need to use parentheses, or your brain, one or the other. Average rate of change. If you have never done your homework, you probably don't remember what this means. Can you help your friends remind what average rate of change is synonymous with? Slope. So if I want average rate of change between x equals 4 and x equals 2, that means, because you got to find the ordered pairs. So you go find your 2 ordered pairs. Yes, you will have to plug it in. So you find the y values that are associated with that, and then you go find slope. So it's a couple of evaluations combined with the slope formula. All right. Knowing whether a graph is a function or not, if it's graphed for you, how do you determine whether it's a function? If it passes or fails the vertical line test. Very good. So you do need a picture for that. If you're going to tell me it's a function because it passes the vertical line test, well, what else would you have to provide for me on this question? Yeah, you'd have to draw it. Sketch something.
You?
Yeah. You can't tell me it passes the vertical line test and not show me the vertical line test. That's not how that works. So on the follow-up question there, draw something that is not a function. You're going to draw me something crazy that fails the vertical line test. Yeah, Hofbauer's picture on her key is weird. No offense, Hofbauer, but that got crazy. Oh, this one. Man, I'm worried about this one. Okay. So here's your function. They want you to evaluate it at not a number this time, but some algebra. So you're going to write the skeleton out. That's the first step. And then everywhere you see an x, you're going to replace it with a minus 4. And I think y'all know what I'm worried about.
You've got to not distribute.
Yeah, we need to foil this out. There's 2 problems. Some kids are going to forget that this is not a simple distribution of the exponent. You have to actually foil this. The other problem is the 3. You have to kind of hold your horses on distributing the 3. Don't do it yet. So 3 stays in front. foiling this out, you're going to get a squared minus 8a plus 16. I know I went really fast there, but I'm sure you guys can come up with that. And then you can go ahead and distribute this one, minus 6a plus 24, and then plus 7. And then now when you distribute the 3, woo, now you can clean up everything and you'll be done. There's some homework questions that look just like that. Make sure you've practiced them, number 1, and number 2, you better make sure you have work, because when I'm looking through your homework tomorrow, there's a question that looks like this, and if I see the answer with no work and you're going to tell me you did it in your head, I'm going to say, liar, and I'm going to take away your homework fast.
Isn't there some people that do it? Like,
No one I've ever met.
What's that one dude that like knows like the first like 3,000 digits of pi somehow?
Yeah, that's weird, man. Hey, real quick, I'm worried about this one, just because I'm very worried about this one. What are they asking? They want me to refer to this graph up here. If it says f of 0, walk me through this. What are they giving me? What am I supposed to find? This means x equals 0. What is the function's output? So I go to my graph and I say, here's where x equals 0. And you follow it up. And you're going to tell me the answer is? 3. Very good. So function notation, what's in the function is an x value. You got to go figure out the y value. This question is kind of the newy stuff from yesterday. They want to know if it's continuous at all these various things. Well, guys, you could plug them all in, but I think we have a faster way. I know that rational functions cannot have denominators of 0, right? That's the problem. So what if you just figured out what was a problem? So what if you added a 4, and then you square rooted both sides? So that means x can't be positive or negative 2, because it would be discontinuous. It would have an interruption of the domain. So that's a quick no, yes, yes, followed by a no. So rather than plugging each one in separately, just figure out what's the problem, and then tell me those don't work. That's a lot quicker, isn't it? All right. Good luck. Bye, Jacob. We miss you.